So this is a walkthrough of this number logic puzzle, 1 to 25 we have to put in this grid. So I'll kind of walk through how we're going to do that, and this is a quiz by Nene71 and Sporcle. I'll put the link in the description so you can play along. If we go down to the more information, it just tells us that we need to put in the numbers 1 to 25. They appear once, and you don't need to guess. You can do this just by logic. So we're going to try to do that today to walk through these. I just switched my grid over here so that we match the same because we don't want it to be confusing. I just got this Excel document to help us when we're thinking about things. We don't have to have this screen up because we've got a 20-minute timer. We're not going to do it in 20 minutes. It's going to take us longer than that. So we'll have kind of all the numbers written in here eventually. So this one first of all tells us that this square is 12, and it gives us a clue. All the corner numbers are factors of this one, and C3 is divisible by this one. So the corners are all factors of 12. And then C3, which is this spot, is divisible by 12. So we'll put in there divisible by 12. Just pause that on this screen, or you can go back to our grid up here. So I like to just colour them when we're done so that it's all very clear what to do. So let's think about the factors of 12. We've obviously got 1 and 12. We've got 2 and 6. We've got 3 and 4. They're all the factors of 12. So the corners, obviously 12 itself is taken. But we know that the other corners could be 1, 2, 3, 4, or 6. And then we know that this centre number, C3, is divisible by 12. So the only number in this quiz that's divisible by 12 other than 12 itself is 24. So we must have 24 in this centre spot, which I'm sure is going to give us a bit more information. We can't do much more with this at this moment in time, so we'll come back to that in a sec. Let's just put in our 24 into the centre. All numbers in column 5, so this column here, are even. So just going to put an E in each of them to show that they're all even. And A5, so this one here, times by, A5 is equal to 2 lots of E5. So, yeah. So, double E5 makes A5. So, we'll just pop that in there. Sorry, which way around is that? E5 doubled is A5. So 2 E5. Put in a times there. 2 E5 is equal to A5. So, of these two corners, they're the most interest at the moment because we want even numbers that are also factors that are also double each other. So if we talk about just even factors, we've got 2, 4, and 6. There are the options for these even factors. We can't have 1 and 3 obviously because they're not even. Same down here, 2, 4, and 6. But then we know that E5 doubled makes A5, so if that was a 2, that could be a 4. If it was a 4, it can't be an 8, or a 6 can't make anything. So that leaves us with just the one option. 2 doubled makes 4. So 2 and 4 are in there. Tick them off on here. And then this spot is the only one left. We've used the 2 and the 4 now here, so we can get rid of them. So we're now left with only the options 1, 3, and 6. Since there's not many options, I'm just going to write it in so we can see. And I'm just going to kind of highlight that cell a little bit to say these are all the options that are in there. These even numbers, obviously there's loads of even numbers that could be. So we don't really know enough about that yet to warrant doing any more with that. And we can kind of get rid of this as well because we know that all of them are kind of complete. So we've got no more information, but we did put in 2 cells, so we can put that back in on the other screen. So pop that over there. We've got 4 at the top here. D2 is the square of E1. So E1 down here squared gives us D2. So I'm just going to put in there square of E1. And down here we've got number 2. There are 4 prime numbers in column 2. So this is 4 prime. So we've got, now we know that this is a square number. Square numbers obviously can't be prime numbers. Prime numbers are underlined on my grid here, which means that the other 4 numbers have to all be prime. And then we'll think about the square of E1. If E1 was a 1, that would make this one also a 1, which can't happen because you can't have the same number twice. A 3 would make this one a 9, so that's an option. Or a 6 squared would make a 36, which is obviously too big for this. So that leaves us just with the one option, which is that being a 9 and that being a 3. So we've got the 3 and the 9 in there. Pop them with the colours to show that they're done. So we can get rid of this 4 prime. We know that all of these now are prime going down, but there is a lot of options for prime. 5, 7, 11, 13, 17, 19, 23. That's too many really to write in. Same for all the even numbers, obviously that's nearly half the numbers, so not much point writing them all in at this point, but we've got these references just to help us. But we can write in the 9 because we've got that, and the 3 as well, and we can read these clues. The numbers in this column, so the second column, are in descending order from top to bottom, so they're going down top to bottom. So in other words, this is a prime that is less than 9, and this is a prime that's bigger than 9, and then bigger than that one, bigger than that one. So that'll help us. So we want to just put descending, and then we've got this equation here. So we've got 2 lots of C2, which is this one. Let's write this here. 2 lots of C2 is equal to B5, which is this even number here, plus C5, which is this even number. Sorry, not equals, plus. Let's start again. 2 lots of C2 is B5 plus C5, which is also equal to D5. Interesting. Okay. That's all we've got so far, so let's work with that. So let's think about primes less than 9 to start off with. We've got 2 options, they're 5 and 7. So we kind of might as well write them in, because there's only a couple of options. And again, we can highlight with this lighter orange to show that that's kind of all the options. This one, going up, we could have anything bigger than 9 that's prime. So the options are 11, 13, 17, 19, 23. But then we've got to go up again and again. So there's not going to be too many options. So I think we probably could write these in. We could have 11, 13, 17. Now if we had 19 in this spot, say we had 19 here, we'd have to have 23 there and we'd have nothing left. So that tells us we can't have 19 in there. Then this one can't be 11 because it's got to be bigger than 11 now. So I've got 13, 17, 19. Can't be 23 again because there'd be nothing bigger. And then this one, 13 in there would make this one, the lowest it could be is 17. Could be 19 or it could be 23. So again, all them spots are done in the sense that they've got everything in that we want from them. And we can kind of highlight it to say that's all the options that are in there. So let's come to this equation. We've got 2C2. Now C2 only has these options of 11, 13 or 17. So it could be 11, 13 or 17, which, let's put them actually, let's get them over here. If that was C2, then that means that 2C2 would be the double of these two. So we'd have 22 or 26 or can I add 34 times, sorry, yeah. So we'd have two lots of C2 there. Now, we know that that is equal to this, B5 plus, B5 plus C5. So both of those added together. But it's also equal to D5 on its own. Now 34 and 26 are both too big for this quiz. It only goes up to 25, which means the only option left is 22. So this D5 must be 22, which works for the even number. Means also that this C2 is 11. So we can put in C2 as 11. That could still be 13, etc. up here. And then we know that these two numbers added together get us to 22. So we want to try to think of two numbers that will add to get to 22. So let's work with what we know so far. Let's just highlight these to not be confused by which is taken and which is not. The lowest even number that's left is 6. And so this would either be for B5, let's say, or C5. We couldn't tell which way round it is yet. And we want that to equal 22 as the result. So what add to 6 gets us to 22? That's going to be 18, which is available, so that works. The next is 8, which would be 16, which works as well. The next is 10, which would be 12. I think I've done something wrong here, hold on. Yeah, I can't add. Right, let's take that back, let's start again. Oh dear, can't add. That's not a good start. 6 would get us 18, is that right? Sorry, 16. I really can't add. Right, that's right now. Then the next one could be 8 and 14, which could work. Next one would be 10 and 12. Now, 10 and 12 can't work because 12's already taken. It's up here. So that can't work. And then anything bigger would get 12 would be 10, and we'd kind of loop around on ourselves. So that means the options for these could be 6 and 16, which are both available, could work, or 8 and 14. So all the options in here are 6, 8, 14, and 16. They're all the options, and the same below because we don't know which way round these are yet. So they are all the options, but we need to remember this because it's going to help us later. So we'll keep that there because if we find out one of them is a 6, we know the other one's a 16. So we'll keep it like that. But we got some numbers, so let's put them in. We got an 11 here. All the numbers in column 4 are multiples of 5. So they're all in the 5 times table in that column. And A4, which is this one, take away C3, which is 24, is the same as B1, which is this one. So let's just write that here. A4 minus C3 is equal to B1. Did we get anything else? Yes, we got this 22, which might give us a clue, but it doesn't. That's okay, because we've still got stuff to work with. So this A4, we don't know anything about, but the C3 we do. Something take away 24 is going to give us something else. Now 24 is the second highest in the grid. If we had any number lower than it, we'd get a negative number which can't go in there. So we know then that A4 must be 25. It's the only option that's bigger than 24 to go in there. And then obviously 25 take away 24 gives us a 1 in this spot here. So that's all good. And we know that all of these are the 5 times table. So we might as well write them in. We could have 5, 10, 15, 20, and obviously 25's just gone up there. So we can have those numbers here. Now there's there's 5 numbers in the 5 times table up to 25, which means that these are complete. There can't be anything else in there. Which means that 5 particularly can't be anywhere else, because if it was, we could have 10, 15, 20, and we'd have no numbers left, which means the 5 can't be in this one. So we're only left with a 7 as the prime number at the bottom there. That's our only option left there, because the 5s are all taken by here. So we've used that bit of information. We still don't know about this, but that's fine. We got this 25 at the top here to put in, which doesn't give us anything, but we also got this 1 below the 12, which does give us something. It says B1, which is a 1, plus E2, which is a 7, so 8 is equal to C1. So C1's an 8. Straight away we can get that. 8's then taken, so it can't be in this spot over here. Let's just go back to that for a minute. It can't be in this spot either. But remember then, that means it can't be 8 and 14 as a combination, so it's got to be 16 and 6. So we can get rid of that 14 as well. 16 and 6 are then locked into those 2 spots in some order. Don't know exactly the order, but we can get rid of them on here by putting this light orange there, because it's definitely in there. Same for all these 5 times tables, they're definitely in those spots. We can't do the same here with these primes, because one of the 4 primes, 13, 17, 19, 23, 2 of them are not going to be in there, they'll be elsewhere in the grid. But we got some information again from that. We got that 8 is in here. Oh, wrong side. Let's just undo that before we mess up again. So we got an 8 in there. D1 is the sum of the corners. It tells us D1 straight away. We just have to add up the corners. 12, 16, 17, 18, 19, 20, 21. So we can immediately put the 21 in there. 2 of the 5 columns are in descending order. So going down in descending order. We can have a look at that in a sec. But we also got this 7, which I don't think will give us anything. And that's it for now. So 21 is locked in there. So what have we got? This one is not descending or ascending, it's just random. This one we know is descending already. This one, we only know this 24, but we know it can't be descending, because if it was, we're going down, then we can't have 2 numbers bigger than 24, because 25 is already gone, there's nothing else bigger. So it can't be this one. This one could work. We could have 25, 20, 15, 10, 5. That could work. This column can't work though, because we've got a 22 in here and a 4 at the top. So 4, then getting lower. 22 doesn't work. So that tells us that this one is descending, since there's only 4 options for each box. We have to go in the order that I said: 20, 15, 10 and 5, just like that. It tells us loads in one go, so that's great. This one's now redundant, don't really need these. Well, we can keep this descending for this one so we don't forget that, but we don't really need them. We've used that. We just need to keep, well, we don't need to keep that actually, because now we know that they're the only 2 options. They will definitely times together. So lots more information to write in. We got a 20 here. All numbers in row E are smaller than the numbers directly above them. So this number is going to be smaller than this number. So put smaller than D3. We'll sort that in a minute. Let's just put in the rest of the numbers. We've got 15 in here. D3, which is this number here, plus E3 is 27. Okay, D3 plus E3 is 27. 10 there, 5 there. Might not give us anything else now. That's it. So let's sort out that so we can see what it says. So smaller than D3. Let me just highlight that one because that's gone. I think we should have, not counting those, 1, 2, 3, 4, 5, 6 numbers left. 5, 6, lovely. 8 including those 2 that we know where they are. So this should say add. We need 2 numbers to add to 27. So we also know that D3 is smaller. So if we start with D3 and E3, and we want the sum to be 27. Let's make it easy for ourselves by giving us a little equation. So if we had the next available number here, which is 13, and 13 add what would get us to 27, so 14 would work. I don't know why that's orange, but it is. And then if we actually go any higher, 14 obviously is 13, that's actually the only option that's available. And because we know that D3 is smaller, we can tell you that that's 13 and then a 14 above it. It's actually the only option that's left in here. So that's nice and easy for us. So we've got a 14 here and a 13 below it. B4 is larger than each number in column 2. B4 is 20. Is bigger than all the numbers in here. In other words, 23 can't appear in here because it's too big. Now, if this one was a 19, remember this is getting bigger as you go up, couldn't be anything left, so that can't be then a 19. So it could be a 13, 17, 13, 19, or it could be a 17 and a 19. But we don't know about that yet. Okay, is there anything else to know? No. Right, what are we missing then? Well, the numbers that are left are 17, 18, 19, 23. So 23 now can't be in this column, which means it has to be in one of these 2. And because these are prime, can't be 18 either. So we know then that these 2 are either 18 or 23. Same in this spot, 18 or 23 only. Which means does that mean? Ah, well, I forgot about this. We've used a 13, so the 13's gone from here, which only leaves 17, which makes this a 19. We've only got 18 and 23 left in there. So let's just pop that there. Nearly done now. We've got a 19 there, a 17. A3, this one, is equal to 3 lots of B5. So if we look at 3 lots of 16, that's going to be too big for this grid, so there must be a 6 in there. 6 times 3, 6, 12, 18, makes that an 18. Then we're left with 23 there and 16 there, just as a process of elimination. So we've got 18, 23, and over here we've got 6 and 16. There we are. So we did that in 26 minutes, which is not bad at all. Again, I'll put the link in the description if you want to play along. This is by Nene781. Hope you enjoyed this tutorial and it helped you to kind of see the logic of each thing. And yeah, hope you enjoyed.